Hey guys, tonight we are standing in the soft dark of an ordinary night, looking up at two very different invitations in the sky. One is the moon, pale and close, hanging there like a quiet lantern above the rooftops. The other is Mars, smaller, warmer in color, a little ember set much farther back in the black. From down here, they both seem reachable in the same dreamy way, just two places beyond the clouds, two neighbors waiting patiently beyond Earth's blue air. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And if you feel like it, write your location and local time in the comments, because it is always lovely to imagine all these quiet rooms around the world, listening under different skies. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. You can picture yourself outside, maybe wrapped in a blanket, maybe sitting near a window where the glass has gone cool. The moon is easy to trust. It rises with a familiar face, bright enough to silver the edges of trees and rooftops, close enough that its craters show through a small telescope like thumbprints in dust. For most of human history, it was the farthest place that still felt personal. It followed farmers, sailors, poets, tired students walking home, and cats making very serious night patrols for reasons known only to cats. Mars feels different. Even when it shines brightly, it remains a point, a reddish dot, a quiet spark. It does not show you valleys or mountains with the naked eye. It gives you almost nothing at first, which is rude, honestly, but also beautiful. It asks for patience. It asks for instruments. It asks for mathematics, timing, rockets, life support, and a willingness to cross a space that looks empty but behaves like a very precise clock. And this is the first gentle truth of the evening. The moon is far, but Mars is far in another way. The moon sits about 384,000 kilometers from Earth on average. That number sounds large because it is large, but you can soften it into an image. If Earth were a basketball, the moon would be a small ball about 7 meters away, maybe across the room or just beyond the porch. You could almost point to it and feel that it belongs to the same little scene. Light from the moon reaches your eyes in a little over 1 second. When you look at it, you are seeing something almost immediate, almost present, almost touching the same moment as you. Mars does not live in that kind of closeness. Its distance changes constantly because Earth and Mars both move around the sun, each along its own wide path. Sometimes Mars comes relatively near, around tens of millions of kilometers away. Sometimes it waits on the far side of the sun, hundreds of millions of kilometers from us. If the moon is a quiet house across a field, Mars is a lantern moving beyond several mountain ranges, sometimes visible, sometimes hidden, always following its own road. That moving distance matters more than it first seems. The moon gives us a target that is always nearby by space standards. It circles Earth every month, almost like a companion keeping pace. Mars belongs to the solar system more deeply. To go there, you are no longer simply leaving Earth. You are entering the rhythm of planets. You can feel the difference if you imagine tossing a paper boat across a pond versus sending a message in a bottle into a river system. The moon is the pond. Wide, yes. Cold, yes. Still demanding respect. But Mars is the river system where everything moves, curves, and arrives only when the current allows. Earth is moving around the sun. Mars is moving too. The spacecraft must leave Earth at the right moment, with the right speed in the right direction, so that months later it meets Mars at the place Mars will be, rather than the place Mars was when you started. That is a calm but important kind of difficulty. The moon journey of Apollo took about 3 days. 3 days is long enough for silence to become noticeable, long enough for Earth to shrink in the window, but still short enough to feel like a passage. A long weekend if your weekend involves a Saturn V rocket, vacuum, and an extremely serious checklist. Mars takes months. Many mission designs take around 6 to 9 months just to arrive. That is not a visit across the night. That is a season of travel. And during all that time, Earth becomes smaller behind you. Keep that image nearby. It will matter later, but for now, just hold it softly. Earth shrinking from a world into a glowing disk, then into a bright star. The moon, when astronauts went there, still allowed Earth to dominate the sky. From the lunar surface, Earth looks large and luminous, about 4 times wider than the moon looks from here. It hangs there, blue and white, almost impossibly alive. The home world remains visible as a place, not an idea. On Mars, Earth becomes a star. A bright one, yes, but still a star. Something you could cover with a fingertip. Something that twinkles in the evening sky like a memory made of light. That one visual fact tells you a great deal about why Mars is harder. The moon keeps Earth emotionally close. Mars gently removes the feeling of immediate return. The moon also lives inside Earth's gravitational neighborhood. It is held by Earth, shaped by Earth's presence, tugging the oceans into tides, reminding the planet that companionship can be mathematical and romantic at the same time. Mars is independent. It is another planet with its own day, its own seasons, its own polar caps, its own ancient scars. It does not orbit Earth. It does not wait for us. It moves around the sun like we do, and any journey there must respect that larger dance. You can imagine the moon as the first quiet step away from home. You walk out into the yard at night. The windows are still glowing behind you. Someone inside might still be making tea. Mars is the road beyond the last streetlight where the houses grow distant and the sky opens wider than expected. Nothing about that road is angry. It is simply spacious. Space does not rush to help. It just is. This is why the moon became our first other world. It was difficult enough to demand genius, courage, and a lot of metal shaped very carefully, but near enough to allow quick communication, short travel times, and emergency possibilities that still belong to the human scale. Mars stretches those comforts until they become thin. Even the way we see these worlds from Earth hints at the difference. The moon has phases you can follow with your own eyes. Crescent, half, full, fading again. It teaches you its rhythm from childhood. Mars has oppositions, retrograde loops, changes in brightness, moments when it comes close and glows with unusual confidence. But those rhythms are slower, more subtle, more planetary. You need to watch for weeks and months to feel them. Mars rewards long attention. And that is the mood of Mars. Long attention, long patience, long silence. The moon says, "Come here and learn how to leave Earth." Mars says, "Come here and learn what leaving Earth really means." There is no need to rush that thought. It can settle slowly. The moon is still astonishing. Nothing about its closeness makes it easy in an ordinary sense. It has no air to breathe, no rivers, no forests, no warm porch light except the sunlight pouring unfiltered across its gray plains. It is harsh in its own quiet way. Yet compared with Mars, it sits within reach of a short chain of days. Mars waits across a gulf measured in months. Orbital timing, radiation exposure, supplies, and trust in machines that must keep working far from any repair crew with a toolbox and a slightly annoyed expression. So as you look from the moon to Mars in your mind, the whole story begins with distance, but not distance as a number on a page. Distance as delay, distance as planning, distance as loneliness, distance as beauty, distance as the way Earth changes from a world beneath your feet into a pale light in the sky. And somewhere in that soft red dot, beyond the moon's familiar glow, the harder journey is already waiting, quiet and patient, as if the universe has no interest in rushing. The harder journey, begins in a silence that is easy to underestimate. You have already pictured Earth shrinking behind you, the moon hanging closer like a silver stepping stone, and Mars waiting farther out as a red point with its own patient rhythm. That rhythm is the secret doorway into the next difficulty. A rocket cannot simply aim at Mars like an arrow aimed at a painted target. Mars is moving. Earth is moving. The spacecraft is moving too, and the sun is holding all of them in a wide, invisible dance. So the journey to Mars begins before the engines ever rise from the launch pad. It begins with waiting. Every 26 months or so, Earth and Mars reach a useful arrangement. They come into the right kind of angle around the sun, and for a short season, the road between them becomes reasonable. Reasonable, of course, is a very space agency word. It still means fire, fuel, heat shields, guidance computers, and people in rooms drinking very serious coffee. But compared with the rest of the time, this window is the gentle opening in the clockwork. If the moon is always circling nearby, offering a new route every few days, Mars is more particular. Mars is the friend who lives far away and owns one calendar. Miss the right time, and the next good chance waits more than 2 years. This is one reason Mars missions feel so different from moon missions. A lunar mission can be planned around many possible launch days. A Mars mission gathers itself around a narrow doorway, and once that doorway opens, the whole machine of human effort has to be ready. The path itself is also strange in a beautiful way. A spacecraft going to Mars usually travels along a curved solar orbit, almost like it is becoming a small artificial planet for a while. It leaves Earth's neighborhood, falls into a new path around the sun, and gradually meets Mars months later. The old classic version of this trip is called a Hohmann transfer, named after the engineer who described the elegant idea of moving between orbits with careful engine burns. The name sounds formal, but the image is gentle. A small craft moving from one circular road to a wider one, using the sun's gravity as the great quiet center. You do not fly straight across the gap. A straight line would seem natural on a map, but space maps lie in the friendliest possible way. They flatten something alive and moving. In reality, the spacecraft is always curving, always falling around the sun, always sharing momentum with the Earth it came from. It is less like driving across a bridge and more like stepping onto a moving walkway that bends around a cathedral. During the Apollo journeys, astronauts crossed from Earth to the Moon in about 3 days. 3 days gives a mission very little room for boredom to become a landscape. Mars offers a much longer quiet. Robotic missions often cruise for 6, 7, 8, sometimes 9 months, depending on the launch energy and the route. A crewed mission would likely spend a similar span crossing that enormous dark, unless future engines make faster paths practical. That long crossing changes everything. A spacecraft must carry power, guidance systems, thermal control, food if people are aboard, water, spare parts, medicine, software, and all the small hidden necessities that never get heroic posters made about them. Filters, seals, pumps, connectors, valves. The humble little things that keep a voyage alive while the planets slowly change places. Space exploration is glamorous from far away and wonderfully fussy up close. Somewhere in the background, a tiny gasket can become the most important object in the solar system, which feels dramatic for a gasket, but there it is. The spacecraft also has to stay healthy for months in deep space. Sunlight grows weaker as it travels outward, though at Mars it is still strong enough to power many machines with solar panels. Temperatures shift depending on where the craft faces. One side can face sunlight while another faces deep darkness. Systems must warm themselves, cool themselves, point antennas, manage batteries, correct their path, and keep listening for faint instructions crossing space at the speed of light. Even without people aboard, the cruise to Mars is an exercise in patience. A small course correction may happen weeks after launch, then another later, each one gentle and precise. A tiny push from thrusters can decide whether the craft arrives in the right corridor near Mars or passes by too far away, becoming another quiet object circling the sun. Space does not need to be dramatic to be unforgiving. It can be perfectly calm while asking for exactness. And still, there is beauty in that exactness. You can imagine the spacecraft in cruise, turning slowly to keep its solar panels lit, its antenna pointed home, its instruments resting or checking themselves in the dark. Behind it, Earth and the Moon are two lights close together. Ahead, Mars grows from a reddish star into a small disk. Day by day, the geometry changes. The craft is not chasing Mars so much as arriving beside it at an agreed-upon place and time, like meeting someone on a train platform after both of you have crossed an entire continent. This is why the phrase "going to Mars" is softer and stranger than it sounds. The destination is real, with canyons, volcanoes, ice, dust, and ancient riverbeds, but reaching it means honoring motion. You cannot bully your way through orbital mechanics. The planets behave with a calm that does not negotiate. They simply continue. Earth moves at its pace, Mars moves at its pace, and the spacecraft enters the rhythm between them. The Moon journey keeps you inside Earth's immediate story. Mars draws you into the Sun's story. That difference feels almost emotional. The Moon is close enough that rescue, though never simple, remains imaginable in a human time frame. A problem on a Mars-bound spacecraft becomes a companion for months. Every decision must be more self-contained. Every system must be more trustworthy. Every kilogram matters, because launching mass from Earth is expensive in energy, and carrying extra fuel to go faster means carrying more fuel to push that fuel, which is the sort of cosmic budgeting that makes rockets seem both brilliant and slightly exhausting. And yet the long crossing is also part of the attraction. It stretches the mind. It turns travel into contemplation. A Mars mission is a long arc through sunlight, a quiet commitment made across millions of kilometers. The spacecraft leaves one world and aims for another by trusting mathematics so deeply that months later, after Earth has moved and Mars has moved and the craft has moved with them, all three meet in the dark with astonishing grace. Keep that image nearby. Three moving points, a quiet agreement, a red world slowly widening ahead. The journey has carried you across the open sea between planets, but arrival is only the next kind of difficulty. Mars is no longer a dot. It is becoming a place, and a place has gravity. The red world has stopped being a dot, and the quiet agreement between moving planets has brought you close enough to see Mars as a real place. It swells slowly in the window, copper and butterscotch and dusty rose, with pale polar caps resting at the top and bottom like small, frozen thoughts. The black around it feels deeper because the planet is no longer only light. It has shape, it has weight, it has a pull. That pull is where arrival becomes serious. On the Moon, gravity is gentle, almost shy. It is only about 1/6 of Earth's gravity, so a human body feels strangely light there, and a spacecraft descending toward the surface can be slowed with rocket engines in a fairly direct way. The Moon has no meaningful atmosphere to complicate the descent, nothing thick enough to burn against, nothing to push a capsule around, nothing to catch a parachute. The spacecraft simply approaches a gray, silent surface and uses engines to lower itself, carefully, steadily, with gravity tugging softly underneath. Of course, simply is doing a suspicious amount of work there. Landing on the Moon was never easy. It required astonishing precision, calm nerves, and computers that seemed charmingly tiny by modern standards, like someone asked a calculator to help land a house. Still, the physics had a certain cleanliness. There was vacuum, gravity, and engine thrust. The problem was terrifyingly difficult in practice, but beautifully clear in principle. Mars has a different personality. Mars has enough gravity to pull a spacecraft in hard, much harder than the Moon does. Its surface gravity is about 38% of Earth's, which sounds modest until you arrive at interplanetary speed. After months of falling around the Sun, a spacecraft reaches Mars moving incredibly fast, often several kilometers every second. That is not a gentle stroll toward a red desert. That is a fiery appointment with a planet that has been patiently waiting to remind you that speed is still speed. Gravity does not feel dramatic from far away. It feels almost polite. The planet grows larger, the path curves more steeply, and the spacecraft begins to fall into a deeper well. That well is invisible, but it has consequences. To land, the spacecraft must get rid of a huge amount of energy. It must turn furious motion into stillness without breaking the delicate thing it carries. This is one of the great quiet differences between the Moon and Mars. The Moon is nearby, and spacecraft can arrive on paths designed for a slower, engine-controlled descent. Mars is farther away, reached by a solar orbit, and arrival carries the memory of that long crossing. The craft is not just above Mars. It is rushing toward a planet after traveling through the architecture of the solar system. The challenge is called entry, descent, and landing. Engineers sometimes shorten it to EDL, because even engineers enjoy pretending three terrifying words are calmer as initials. For Mars, EDL is famous because so much has to happen in a short span of time. A spacecraft enters the upper atmosphere, heats up, slows down, deploys systems, sheds protective parts, fires rockets, senses the ground, and lands. Each event must happen at the right moment, in the right order, with very little room for improvisation. The Moon asks you to bring your own brakes. Mars also asks you to bring your own brakes, then adds a thin atmosphere that tries to help and misbehave at the same time. That detail belongs more fully to the next part of the journey, but it begins here as a shadow across the landing problem. Mars gives you air that can slow a spacecraft, yet the air is too thin to make landing easy by itself. So the craft must use a heat shield, parachutes, rockets, or sometimes stranger inventions, all braided together into one careful descent. You can picture a lander reaching Mars like a seed wrapped in fireproof shell. The first contact is with the upper atmosphere, so faint it would feel almost like nothing to a human hand, yet at high speed it becomes powerful. The heat shield glows. The spacecraft shudders gently through plasma and pressure. It is slowing, but the surface is coming closer. Mars is helping, but not enough. Very considerate, very inconvenient. On the Moon, the lack of atmosphere means no heat shield is needed for landing from lunar orbit. A lander can descend under rocket power, with no wind, no aerodynamic forces, no parachute guesses. Mars brings more layers. The planet is neither airless like the Moon nor comfortably thick-haired like Earth. It sits between categories, and in spaceflight, between categories, is often where the headaches live. There is another subtle problem with gravity. Mars is strong enough that hovering is expensive. Every second a lander spends firing engines near the surface uses precious fuel. The craft needs to slow down quickly, but also gently enough to survive. It must avoid tipping, avoid bouncing, avoid landing on a rock, and avoid kicking up so much dust that instruments, engines, or sensors are confused. A soft landing is really a negotiation between mass, speed, fuel, atmosphere, computers, and terrain. And terrain matters. The Moon has rough places too, with craters, boulders, slopes, and powdery regolith. Mars adds a wide variety of landscapes shaped by ancient water, volcanoes, wind, ice, and impacts. Smooth plains exist, but the most scientifically interesting places are often less cooperative. A river delta is wonderful for studying ancient habitability. A canyon wall can reveal history in layers. A rocky field, however, has the bedside manner of a spilled toolbox. Science wants the good stuff. Landing systems prefer a calm, flat parking lot. The universe rarely offers both in the same convenient rectangle. That tension is part of why Mars feels so hard. To understand the planet, missions aim for places with meaning. To survive the arrival, they need safety. Each landing site is chosen through a long balancing act, where scientists dream of ancient lakes and engineers quietly ask where the rocks are. Both are right. Both are needed. Imagine standing beside the moon in memory, with the lander easing down on rocket flame into silent dust. Then carry that image outward to Mars, where arrival begins with fire, then fabric, then engines, then cables or legs or wheels, all while the planet pulls steadily below. The difference is not only distance, it is the style of arrival. The moon allows a kind of directness. Mars requires a sequence, almost a choreography, performed by a machine alone. And during that choreography, Earth can only watch from far away. By the time a signal reaches Earth saying the spacecraft has entered the Martian atmosphere, the landing may already be over. The whole descent happens faster than conversation can cross the gap. Engineers receive the story after the machine has lived it. That delay will matter more later, when you hear the strange patience of interplanetary communication, but here it adds a soft hush to the landing. The spacecraft must carry its own judgment. It must sense, decide, and act in the thin red sky. So the planet that looked so peaceful from far away begins to reveal its careful demands. Mars is beautiful, but it does not hand out easy arrivals. Its gravity gathers you in. Its surface waits. Its thin air whispers across the heat shield, promising help, offering complications, and preparing the next quiet lesson. That thin red sky has a strange sense of humor. From orbit, Mars looks calm enough to trust. Its atmosphere softens the edge of the planet with a faint golden haze, a delicate veil above deserts, craters, volcanoes, and old riverbeds. It seems almost welcoming from a distance, as if the planet has wrapped itself in a little air just for the sake of politeness. After the clean silence of the moon, even a whisper of atmosphere feels like a gift. Then you arrive at landing speed, and the gift comes with paperwork. Mars has an atmosphere, but it is extremely thin. At the surface, the air pressure is usually less than 1% of Earth's. If Earth's atmosphere feels like a deep ocean above your head, Mars has something more like a high, ghostly mist. It is mostly carbon dioxide, with only tiny traces of oxygen, nitrogen, argon, and other gases. You could stand beneath that pink sky in a pressure suit and look across the horizon, but the air around you would be far too thin to breathe. It would also offer very little protection from the cold, or from radiation arriving from space. And yet, for a spacecraft moving incredibly fast, that thin air still matters. Speed changes everything. A gentle breeze on your face is soft because you are moving slowly through thick air. A spacecraft entering Mars's atmosphere is moving so fast that even thin gas becomes powerful. Molecules slam into the heat shield. The craft compresses the air in front of it. Heat rises. The outside glows. The atmosphere that seems almost absent from the ground becomes a serious force during entry, as if Mars has been saving all its drama for the arrival. This is why Mars is awkward in such an elegant way. Its air is thick enough to create heat, pressure, turbulence, and uncertainty. It is thin enough that parachutes struggle to do the whole job. Earth's atmosphere can slow a returning capsule from orbital speed to a manageable descent with a combination of drag and parachutes. The moon, having no real air, gives engineers a vacuum problem, clean and direct. Mars lives in the middle, and the middle is complicated. A parachute on Mars has to open at high speed in thin air. It must be huge, strong, and carefully shaped, because there is so little atmosphere for it to grab. Even then, it cannot slow a heavy spacecraft all the way to a soft landing. Earlier missions used airbags, bouncing over the surface like very expensive beach balls with science inside. Later, heavier rovers needed rockets. The Curiosity and Perseverance rovers used a sky crane system, which sounds like something invented during a very calm fever dream. A rocket-powered platform lowered the rover on cables, placed it onto the ground, then flew away to crash at a safe distance. It sounds theatrical, but it solved a real problem. A large rover could not be dropped, could not rely only on airbags, and could not easily sit on top of a rocket stage without covering itself in dust or needing a ramp. So the rover was gently lowered, wheels first, onto Mars. Quietly dramatic, almost graceful, also extremely rude to anyone's blood pressure in mission control. The atmosphere also changes from day to day, season to season, and place to place. Mars has weather. It has winds, clouds, frost, dust devils, and enormous dust storms that can spread across regions or, on rare occasions, wrap around much of the planet. The air is thin, so the wind would not push on you with the same strength as Earth wind at the same speed, but the dust is fine and persistent. It hangs, drifts, coats surfaces, dims sunlight, and works its way into the story of almost every mission. During landing, density matters. If the atmosphere is a little thicker or thinner than expected along the path, the spacecraft may slow down more or less than planned. Engineers build margins for this, and they model the Martian atmosphere with great care, but Mars keeps its own habits. Dust can warm the atmosphere by absorbing sunlight. Seasons shift carbon dioxide between the air and the polar caps. The whole planet seems to breathe faintly over the Martian year, growing and shrinking its atmosphere by small amounts as carbon dioxide freezes and sublimates near the poles. That soft breathing is beautiful from far away. Up close, it becomes one more thing to understand. The color of the sky also tells a quiet story. Mars often has a butterscotch or salmon-colored daytime sky because fine dust scatters sunlight through the atmosphere. Near sunrise and sunset, the light can shift in ways that feel almost reversed from Earth, with bluish tones near the sun. The dust changes the path of light, painting the sky with delicate strangeness. You can imagine a rover sitting still at dusk, its mast turned toward the horizon, watching the sun sink as a small pale disk in a dusty blue glow. The scene is gentle, almost dreamlike, but every bit of that beauty comes from physics: particle size, sunlight, scattering, air pressure, and dust suspended in a planet's thin breath. For humans, this atmosphere is a challenge at every scale. It cannot be breathed. It cannot provide enough pressure for an unprotected body. It cannot warm the surface in the familiar earthly way, but it can be used. That carbon dioxide may become a resource. Future explorers may draw it in and process it to make oxygen, and perhaps even fuel ingredients. A small experiment on Perseverance already showed that oxygen can be extracted from Martian carbon dioxide. It was modest, but deeply important, like hearing the first note of a song that might one day keep people alive. So Mars's atmosphere is trouble and promise together. It resists easy landing, shifts with dust and seasons, paints the sky, chills the ground, and stores material that future missions may learn to use. It barely helps in the way you might wish, but it helps enough to matter. That is Mars all over. It refuses to be simple. It offers just enough to keep the dream alive, and just enough difficulty to make the dream grow wiser. Down on the surface, after the heat shield has fallen away, after the parachute has drifted into the dust, after the rockets have gone quiet, the atmosphere remains. Thin, cold, restless. It moves softly around wheels, solar panels, rocks, and silent instruments. It carries dust across plains that once may have held water. It hisses gently over machines built on a blue planet, machines that must endure night after night beneath a sky that can glow with morning frost and afternoon haze. And once the landing is over, Mars reveals a slower test, one that does not arrive in fire or parachutes, but in patient grains of dust, long cold evenings, and the quiet need for machines to keep working alone. The first quiet thing you notice after landing is that Mars does not rush to reveal itself. The drama of arrival fades. The parachute is somewhere behind you. The heat shield is resting in the distance. The rockets have gone silent. And all around, the surface stretches outward under a pale sky, still and rust-colored, as if the planet has been holding this pose for millions of years and sees no reason to hurry for visitors. The machine that has arrived there, whether rover or lander, begins its slower life. It checks itself. It unfolds. It listens. It looks around. It sends home a few careful images, and on Earth, people lean toward screens with the strange tenderness humans reserve for distant little machines doing their best. A Mars rover has no repair crew nearby. No one can walk over with a wrench, sigh politely, and say, "Well, there's your problem." Every wheel, camera, cable, drill, joint, antenna, battery, and circuit has to survive in a place that is patient in the way stone is patient. Mars does not attack loudly. It wears things down softly. Dust is one of its favorite tools. Martian dust is very fine, finer than beach sand, more like powder. It coats surfaces, gathers on solar panels, settles into seams, and rides the wind in slow, reddish veils. It contains iron-rich minerals, which help give Mars its rusty color, and it can cling stubbornly because tiny particles behave differently from the sand you might shake out of your shoes after a day near the sea. On Mars, dust is part of the air, part of the ground, part of the weather, and part of the engineering problem. For solar-powered machines, dust can become a soft, dimming curtain. A clean solar panel drinks in the sunlight and turns it into electricity. A dusty one receives less. The Spirit and Opportunity rovers depended on solar panels, and their long lives were helped by occasional cleaning events, when Martian winds brushed dust away and gave them new strength. It is oddly sweet to imagine the planet itself accidentally dusting off a rover, like a sleepy host remembering manners at the last moment. But Mars is not always so generous. A planet-wide dust storm in 2018 reduced sunlight so much that Opportunity, after years of extraordinary work, could no longer keep itself powered. That rover had been designed for about 90 Martian days and lasted more than 14 Earth years, which is the kind of overachievement that makes even machines seem humble and heroic. Its end was not a sudden cinematic collapse. It was a fading of power beneath a dusty sky, quiet and distant. That is one reason Mars is harder than the Moon. Lunar dust is also a serious problem, sharp and clingy because it has been broken by impacts without weathering in liquid water or air. Apollo astronauts discovered how stubborn it could be. It stuck to suits, scratched surfaces, and smelled strange inside the spacecraft after being carried in. The Moon's dust is troublesome in a clean, airless environment. Mars adds wind, atmosphere, electrostatic behavior, chemistry, storms, and seasons. Dust does not simply sit there, it travels. The cold is another slow test. Mars is farther from the sun than Earth, so it receives less sunlight. Its thin atmosphere holds little heat. The surface can warm in sunlight and then lose warmth quickly after sunset. Average temperatures are far below freezing, and nights can become bitterly cold by Earth standards. A rover sitting on the surface must protect its electronics, batteries, motors, and instruments through this daily rhythm. Warm, cold, warm, cold. Expansion and contraction. Charging and discharging. Heat leaks away. Heaters sip precious energy to keep delicate parts alive. Temperature on Mars is not only about comfort because machines do not shiver in the human sense. It is about materials. Metals, plastics, lubricants, seals, batteries, and circuits all have limits. A wheel joint that works beautifully in a lab must keep working after thousands of cycles in dust and cold. A camera must focus. A drill must bite rock. A robotic arm must move with patience and accuracy. The machine must behave almost like a living thing, conserving energy, resting through cold periods, waking under the sun, responding to commands that left Earth many minutes earlier. And because Mars has a day only a little longer than Earth's, about 24 hours and 39 minutes, mission teams can follow its rhythm for a while. That Martian day is called a sol. A rover might drive a little on one sol, study a rock on another, take weather measurements, send data, pause during harsh conditions, then continue. The rhythm feels familiar and alien at the same time. A day passes, but it is a Mars day. The sun rises smaller in the sky. The shadows fall across another world. The landscape around the rover is full of clues. Rounded pebbles may hint at ancient water. Layered rocks may hold records of old lakes or wind-blown dunes. Minerals can suggest whether water was once neutral, acidic, salty, warm, or cold. Mars today is dry on the surface, but the planet carries evidence of a wetter past. Channels, deltas, minerals formed in water, and valleys that look as though liquid once moved through them. Every rover becomes a slow reader of that old story. The reading takes time because Mars is far away and because rovers are careful. They do not race across the planet like little red sports cars, though honestly, after all this effort, it would be understandable if someone wanted them to. A rover may drive only a modest distance in a day, checking hazards, choosing paths, avoiding slopes, rocks, soft sand, and places where wheels might dig in. The surface can look firm and still hide trouble. Sand traps have ended missions before. A wheel can wear down. A drill can jam. A sensor can become dusty. Mars rewards patience and occasionally charges a fee for impatience. The moon is harsh too, but its nearness changes the feeling of operations. Communication is quick. Lighting conditions can be planned around shorter mission goals, and human crews can intervene directly during surface visits. Mars surface missions live by delayed instructions and long autonomy. The machines must make small decisions, protect themselves, and wait when Earth is out of view or when orbiters are not passing overhead to relay messages. There is something deeply moving about that waiting. A rover on Mars may sit through the night with heaters glowing faintly inside, beneath a sky where Earth is a bright point among other points. It has no awareness in the way you do, yet it becomes a kind of presence in the imagination. It is a careful extension of human curiosity, alone in a cold desert, listening to wine that barely has strength, watching dust move across rocks older than every city on Earth. And through those machines, you begin to understand that Mars is not hard only during launch or landing. It is hard in the long middle after the applause fades, when the work becomes ordinary and extraordinary at once. Surviving one night matters, then another, then a season, then a storm, then another slow drive toward a stone that may remember water. The machines teach us how Mars behaves. They also teach us what future travelers will have to face in their own bodies, with their own muscles, bones, sleep, breath, and fragile warmth carried far from Earth. That fragile warmth is the next part of the story, because sooner or later the quiet machines on Mars point back toward the people who built them. A rover can wait through a cold night with heaters tucked inside its body, but a human traveler brings something more delicate across the dark. You bring blood moving in a rhythm. You bring sleep, hunger, balance, memory, skin, breath, and the small private weather of being alive. The moon asks a human body to adapt quickly. During Apollo, astronauts spent only a few days away from Earth and only a short time walking on the lunar surface. Their bodies had to handle launch, weightlessness, pressure suits, low gravity, dust, cramped quarters, and the deep strangeness of seeing home hanging above a gray horizon. That was already a tremendous demand. But the moon sits close enough that the human body is only briefly borrowed by space. Mars asks for a longer loan. On the way there, a crew would live for months in microgravity, where the body begins quietly rewriting its habits. Muscles do not work as hard because they no longer need to hold you upright against Earth's pull. Bones sense that they are carrying less load, and over time they can lose density. Fluids shift upward, so faces may look puffier and legs a little slimmer. Balance changes because the inner ear is used to gravity as a kind of silent reference. Even the heart adapts to moving blood through a body that no longer has a familiar up and down. None of this is science fiction. Astronauts have already lived for long periods aboard space stations, and their bodies show how adaptable humans can be. Exercise helps a great deal. Carefully designed machines provide resistance, so muscles and bones still receive a reason to stay strong. Nutrition matters. Sleep matters. Medical monitoring matters. The body is not helpless in space. It is responsive, practical, surprisingly cooperative, as long as the mission keeps giving it the right reminders. Mars makes those reminders more important because the journey is so long and because arrival is not the end. After months in weightlessness, a crew would reach a planet with gravity about 3/8 of Earth's. That is stronger than the Moon, much weaker than home, and still not something the body has experienced for long durations. A person stepping onto Mars after months in microgravity would need strength, coordination, and caution. The surface would be lighter than Earth, but the suit would be heavy, the terrain uneven, and every movement would happen inside a life support system that turns walking into engineering. You can imagine taking a step in a pressurized suit beneath a peach-colored sky. The ground crunches softly. The horizon sits closer than Earth's because Mars is smaller. The sun looks a little reduced, gentler in brightness, though still sharp through the thin air. Your body, so used to Earth's full gravity, would be learning a new grammar. Each movement would be slower, planned, almost ceremonial. Bend, reach, balance, breathe. Listen to the suit fan. Watch the dust, trust the seals, trust the training. Radiation adds another invisible layer. Earth protects life with a magnetic field and a thick atmosphere, two quiet shields that most days you never have to think about. The Moon has no global magnetic field and no real atmosphere, so astronauts there are exposed more directly to radiation from the sun and from deep space. Mars has a thin atmosphere that offers some shielding, but much less than Earth, and no strong global magnetic field wrapped around the whole planet. During the cruise between planets, the shielding challenge is greater, because the spacecraft is out in interplanetary space for months. This does not make Mars impossible. It makes design important. Spacecraft can use shielding materials. Habitats can be placed partly under soil or covered with protective layers. Mission planners can track solar activity and create safer areas where crews could shelter during solar particle events. The idea is not to make space gentle. Space is not gentle. The idea is to understand its quiet pressures and build a small moving home that can carry human life through them. That small moving home must also handle air, water, waste, food, temperature, and illness. A lunar trip can carry supplies for a short mission with margins. A Mars mission must rely much more deeply on recycling. Water can be cleaned and reused. Air can be scrubbed and refreshed. Carbon dioxide must be removed. Oxygen must be supplied. Every system becomes part of a living loop, almost like a tiny artificial ecosystem with checklists. Food becomes more than calories. It becomes comfort, routine, color, and memory. A warm meal inside a spacecraft may be a small emotional anchor. The smell of something familiar can make a metal habitat feel less like a machine and more like a room. Mars missions would need careful nutrition, but also a kind of psychological kindness. Humans are wonderfully capable, but nobody becomes less human just because they are wearing a mission patch. The mind matters as much as the bones. A crew traveling to Mars would live in a confined space for months, with the same small group of people, far from Earth, in a world of scheduled tasks and limited privacy. The moon missions were brief bursts of intensity. Mars would be a long human season. The crew would need skill, patience, humor, emotional steadiness, and the ability to have a mildly awkward breakfast with someone after a tense workday, because civilization sometimes depends on people calmly sharing rehydrated eggs. There is also the feeling of distance. Remember Earth shrinking from a world into a star. That image is beautiful, but it also changes the heart of a mission. On the moon, Earth fills the sky like a luminous promise. On Mars, Earth is a point of light. Home is present but tiny. The crew would know that help cannot arrive quickly. Medical issues, equipment problems, emotional strain, and ordinary fatigue would need to be handled locally, with Earth offering guidance from far away. That guidance would travel slowly, and the slowness changes the shape of support. A doctor on Earth could advise, but a crew member might need to perform care before a full back-and-forth conversation could happen. Mission control could help plan, but the crew would carry more authority. Mars asks humans to become more self-reliant than any explorers who remain close to Earth. And yet there is calm in that thought too. A Mars crew would not be separate from humanity. They would be connected by light, by radio, by memory, by the work of thousands of people, by every test and simulation that came before. Inside the habitat, every breath would carry Earth's intelligence. Every recycled drop of water would be a little victory of design. Every exercise session, every meal, every quiet check of a pressure gauge would be part of staying alive with care. The human body far from Earth is not simply fragile. It is adaptable. It learns. It complains naturally because bodies have opinions, but it learns. Mars is harder than the moon because it asks that learning to last much longer, across the voyage, across the surface stay, and across the journey home. It asks human life to stretch across planetary distance without losing its warmth. And across that distance, even a simple voice from Earth arrives changed, softened by time, delayed by the dark, turning conversation into something slower and stranger than anything the moon ever required. A voice from Earth does not arrive on Mars like a voice across a room. It does not interrupt. It does not answer quickly. It travels as radio waves, moving at the speed of light, which is the fastest anything in the universe is allowed to move, and even that begins to feel slow once the space between worlds becomes large enough. Near the moon, this delay is small. Light crosses the distance from Earth to the moon in a little more than 1 second. A message can go there and come back in a few seconds, short enough that conversation still feels like conversation. Apollo astronauts could speak with mission control, wait briefly, and hear a reply that still belonged to the same breath of time. The pause was noticeable but human. A question could be asked, an answer returned, a decision shared. Mars stretches that pause into a different kind of silence. Depending on where Earth and Mars are in their orbits, a one-way signal can take roughly 3 minutes at the closest approaches, and more than 20 minutes when the planets are far apart. A full exchange can take twice that. You speak, and then you wait. The other world receives your voice after a delay, sends a reply, and that reply crosses back through space as the planets continue their steady motion around the sun. A normal chat becomes a slow correspondence. A small joke arrives late. A question hangs in the dark. The answer comes back after enough time for a kettle to boil, a song to finish, or someone on Earth to stare at a screen with the special expression of a person trying to remain calm in front of several billion dollars of hardware. This delay is one of the most important differences between the Moon and Mars, because communication is more than comfort. It is how teams solve problems. It is how mission control watches over spacecraft. It is how instructions move, how data returns, how people feel connected to the world that made them. On the Moon, a crew can receive help quickly. If something looks strange on an instrument panel, Earth can respond almost immediately. If a procedure needs adjustment, engineers can discuss it in near real time. The Moon is distant, but it stays inside the rhythm of human speech. Mars does not. A rover on Mars cannot be driven with a joystick from Earth, even though that would be deeply satisfying in a very nerdy way. By the time a command reached the rover, the ground situation would already be old news. The rover must receive planned instructions, carry them out carefully, and use onboard software to avoid hazards. It may stop if it sees danger. It may choose a safe path within limits. It may wait for the next set of commands. This is patient exploration, one carefully approved movement at a time. You can picture a rover facing a field of stones. On Earth, mission planners study images, mark possible routes, consider slopes and wheel safety, choose targets, and send the plan upward through antennas. The message leaves Earth as energy, crosses millions of kilometers, reaches an orbiter or the rover itself, and becomes action on another world. Hours later, images and data return. The humans see what happened after it has already happened. They are steering through memory. There is something strangely peaceful about that. Mars exploration has a rhythm closer to gardening than racing. A command is planted. The result grows in its own time. The planet answers with pictures, chemistry, weather readings, wheel tracks, and dust on the horizon. For astronauts, the delay would feel even more personal. A crew on Mars could still talk with family, friends, doctors, and mission control, but every exchange would carry the softness of distance. No quick back and forth. No immediate reassurance. A birthday greeting might arrive as a recorded message. A child's laugh from Earth would reach the habitat minutes after it was sent, still bright, still real, but touched by the long road it traveled. This sounds lonely, and it could be, but it also creates a deep kind of independence. Mars crews would need to make decisions with confidence. They would train for emergencies, medical care, repairs, science work, and ordinary daily choices without waiting for Earth to approve every step. Mission control would remain vital, but less like someone standing beside you, more like a wise voice across a valley. That valley is made of light. Radio waves and light are both forms of electromagnetic radiation, traveling through vacuum at the same cosmic speed. Nothing is wrong with the signal. Nothing is broken. The delay is simply the size of the solar system making itself known. The Moon teaches distance in seconds. Mars teaches distance in minutes. And those minutes change psychology, engineering, operations, and the emotional texture of the mission. There are other quiet complications too. The Sun can interfere when Earth and Mars sit on opposite sides of it, an alignment called solar conjunction. During those periods, communication can become unreliable because signals passing near the Sun may be disturbed by the charged particles and noise around it. Missions reduce or pause certain commands, giving spacecraft safer, simpler instructions until the geometry improves. Mars keeps working. Earth keeps listening. The conversation becomes quieter for a while, as if the solar system itself has placed a glowing curtain between the two worlds. Orbiters help bridge this silence. Many Mars landers and rovers send data to spacecraft circling overhead, which relay it back to Earth. These orbiters are like patient messengers crossing the Martian sky, collecting whispers from the surface and sending them home with powerful antennas. A rover may wait for an orbiter pass. A lander may store data until the timing is right. Even communication has weather, seasons, schedules, shadows, and angles. That is another reason Mars is harder than the Moon. Around the Moon, Earth is huge in the sky and close enough for direct contact to feel immediate. Around Mars, communication becomes architecture. You need orbiters, antennas, timing plans, autonomous software, fault protection, stored commands, and crews or machines that can continue during silence. The connection is real, but it is stretched thin across a moving gulf. Still, the thought can be beautiful rather than heavy. Somewhere on Mars, a rover finishes a drive and takes a picture of its own tracks fading into red dust. The data rises to an orbiter, crosses the darkness, touches a dish on Earth, and becomes an image on a screen. People see a place no human eye has reached in person. They see stones, shadow, sky, and the faint proof that curiosity was there. A signal from Mars is never just data. It is travel without a body. It is a piece of another world arriving as a pattern, then becoming color, sound, knowledge, and wonder. Across the silent sea, Earth and Mars keep speaking in patient pulses, and each pulse reminds you that distance can slow a conversation without ending it. The next question grows naturally from that silence. If machines must wait, and people must decide more on their own, then a Mars mission cannot depend only on supplies packed long ago on Earth. The red world itself begins to matter in a new way, because staying there means learning what Mars can quietly provide. The red world itself begins to matter in a different way once you imagine staying there. Visiting a place is one kind of challenge. Living there, even for a while, is another. A spacecraft can carry a crew across the dark with food, water, oxygen, tools, medicine, and spare parts packed carefully from Earth. But Mars is too distant for that plan to feel comfortable forever. Every kilogram launched from Earth costs energy. Every supply crate has to survive the crossing. Every backup system needs its own backup. And at some point, the mission begins to look at the planet below and wonder what can be borrowed from the rust-colored ground. Mars is not generous in the warm, earthly sense. There are no forests leaning over streams, no open oceans, no grass bending in a mild wind. The surface is dry, cold, and bathed in a thin light beneath a thin sky. But it is not empty. It holds materials. It holds chemistry. It holds old ice, frozen into the ground in some regions and piled more openly near the poles. It holds carbon dioxide in the atmosphere. It holds minerals in rocks and dust. It holds sunlight, weaker than Earth's but still arriving each morning, quiet and gold through suspended powder. For future explorers, the most precious local resource may be water. Water is heavy, and humans need it constantly. They need it for drinking, for food preparation, for hygiene, for growing plants if a mission attempts that, and for making oxygen and fuel. Mars has water ice, especially near the poles and beneath the surface at higher latitudes. Some spacecraft have mapped hints of buried ice from orbit, while landers and rovers have found direct signs of ice or minerals shaped by water. The planet today is mostly frozen and dry at the surface, but its history whispers of rivers, lakes, and long-vanished wetter environments. Using Martian ice would be a major step toward making Mars livable for a mission. The idea sounds simple in a comforting way. Find ice, collect it, warm it, clean it, store it. In practice, every word in that chain becomes an engineering project. The ice may be mixed with soil. It may sit under layers of dust or rock. It may be too far from the safest landing sites or the most interesting science regions. It may contain salts or chemicals that need careful removal. A machine digging for ice must operate in cold, dusty conditions, with limited power, far from anyone who can kick it gently and pretend that helps. Still, the promise is real. Water can be split into hydrogen and oxygen. Oxygen can support breathing. Oxygen also helps rockets burn fuel. If a mission can make oxygen on Mars, it reduces the amount that must be carried from Earth. That matters because the return trip is not a small favor. A crew needs a way home, and rockets are hungry things. They love propellant in the way cats love knocking objects from tables, consistently, confidently, without apology. Mars's carbon dioxide atmosphere may also become useful. A small experiment aboard Perseverance showed that oxygen can be made from Martian carbon dioxide. It did not produce oxygen on the scale needed for a human base, but it proved the chemistry could work on Mars itself. That matters because the atmosphere is everywhere. Thin, yes. Hard to use, yes, but available. A future larger system could draw in carbon dioxide and process it steadily, making oxygen for breathing or for rocket oxidizer. This is where Mars differs in an interesting way from the Moon. The Moon has useful resources too, including water ice in permanently shadowed regions near the poles and oxygen bound in minerals. It is also close enough that resupply from Earth is much easier. Mars has a thin atmosphere that can be processed, longer day-night cycles that feel more familiar, and a landscape with accessible carbon, oxygen, iron, silicon, sulfur, and other useful elements. Yet distance makes every attempt more serious. If a system fails on the Moon, help may come within days. If a system fails on Mars, the crew works with what they have. A habitat on Mars would be a small island of Earth. Inside, the air pressure would be managed, temperature would be controlled, carbon dioxide from human breathing would be removed, oxygen would be added, water would be recycled, cleaned, reused, and treated as a quiet treasure. Every wall would have a job. Some walls would hold pressure. Some might carry insulation. Some might support shielding against radiation. A habitat could be covered with Martian soil called regolith to add protection. It might sit partly underground, or use pre-built modules, inflatable sections, rigid shells, or combinations that future engineers will argue about very politely for years. The outside world would always be close, only a wall away. On Earth, walls separate rooms from weather. On Mars, walls separate human warmth from a planet that cannot yet welcome a bare hand. That thought could feel heavy, but it can also feel tender. A lamp glowing inside a habitat, boots lying near an airlock, a small plant growing under controlled light, a kettle humming in low gravity. These are gentle images of life making a pocket for itself beneath another sky. Food is one of the deepest puzzles. Carrying all food from Earth is possible for shorter missions, but long stays benefit from growing at least some fresh crops. Plants need light, water, nutrients, temperature control, and protection from the Martian environment. They cannot simply be planted outside in red dirt, despite what some cheerful movie scenes may suggest. Martian soil contains perchlorates in many places, chemicals that create health and growth challenges. The soil also lacks the rich living community that Earth soil has. Microbes, organic matter, worms, roots, rot, all that humble earthy magic. A Martian greenhouse would be more like a careful life support machine with leaves. Power ties all of this together. Solar panels can work on Mars, and they have powered many missions, but sunlight is weaker than on Earth and dust can reduce it further. Dust storms can last for weeks. Panels need cleaning or generous margins. Nuclear power, such as compact fission systems or radioisotope generators for smaller missions, can provide steadier energy through night and storms. A human outpost may need both. Solar arrays spread like dark wings across the dust, and reliable nuclear systems humming quietly in the background, doing the unglamorous work that keeps heaters, pumps, computers, and oxygen systems alive. Living on Mars would be a rhythm of care. Check the filters, monitor the pressure, inspect the seals, recycle the water, watch the weather, clean the dust, tend the plants, repair the drill, save power during storms, study the rocks when the sky clears. It sounds ordinary, and that is exactly what makes it profound. The great achievement would be turning survival into routine, making another planet slightly more familiar one careful day at a time. Remember the rover waiting through the cold night, heaters glowing faintly inside. A human habitat would be that same idea made warmer, larger, and more vulnerable. It would hold laughter, fatigue, work, silence, and the soft sound of fans moving breathable air. Outside, Mars would remain Mars, ancient and cold, with dust sliding across plains under a small sun. Inside, Earth would continue in miniature. And once people learn to live from that rust-colored world, even partly, another question waits in the background like a distant sunrise. Living there is difficult, but leaving again asks for its own kind of courage, its own fuel, its own timing, and its own long road back to the blue star called home. Living there is difficult, but leaving again asks for its own quiet bravery. You can imagine the habitat after many Martian mornings. The dust has gathered in familiar corners. The airlock has its habits. The crew knows the sound of pumps, the rhythm of checks, the small moods of machines that have kept them warm through long nights. Outside, the landscape still looks ancient and patient, with rocks casting blue-gray shadows under a smaller sun. Mars has become less like a destination and more like a temporary address, which is a strange thing to say about a cold desert millions of kilometers from home. But humans do enjoy making routines in unlikely places. Then the return begins to move closer. On the Moon, coming home is hard, but it belongs to a shorter arc. The lunar module lifts from weak gravity, meets the command module in lunar orbit, and the crew heads back to Earth in a matter of days. The Moon has no atmosphere to fight during launch. It has low gravity. It stays close enough that Earth feels like a large, bright place waiting nearby. Every step is still serious, but the road home is short enough to remain almost visible in the mind. Mars makes the road home feel like another expedition. The first problem is simply getting off the surface. Mars' gravity is much stronger than the Moon's, and even though it is weaker than Earth's, a rocket leaving Mars must still climb away from a real planet. It must rise through thin air, guide itself, protect its crew, and reach orbit with enough precision to meet another spacecraft. A Mars ascent vehicle would need to be larger and more capable than the little lunar ascent stage used by Apollo. It would also have to wait on the surface through cold, dust, and time before doing the most important job of its life. No pressure, tiny rocket. Just be perfect after sitting on an alien planet. This is one reason fuel matters so much. Carrying all the return propellant from Earth would make the mission heavier from the very beginning. The rocket to launch the rocket to carry the fuel for the rocket becomes a kind of nesting doll designed by someone with a headache. So many Mars mission plans hope to make at least some return propellant on Mars itself. The carbon dioxide atmosphere can provide oxygen, and if hydrogen is brought from Earth or water is extracted locally, methane and oxygen could potentially be produced for engines. That idea is powerful because it turns Mars from a place that must be fully supplied into a place that can help with the journey home. But helpful chemistry still needs machines. Those machines must land before the crew or arrive with them. They must work reliably in the cold. They must gather, process, store, chill, and protect propellant. They must confirm there is enough fuel before people commit to the surface stay. A crew would want the return system ready, tested, and waiting like a quiet promise. Mars is already hard enough without discovering the gas station is closed. Then comes the timing. Mars and Earth do not stay conveniently arranged. A return trip needs another launch window, another moment when the geometry of the planets makes the path home possible with reasonable energy. This means a crew may need to stay on Mars for many months, perhaps more than a year, depending on the mission plan. The surface stay is shaped by orbital mechanics as much as by human desire. Earth may be visible as a bright point in the sky, but the path back opens according to the slow turning of worlds. There is something beautiful in that patience. A crew cannot simply decide that Thursday feels nice for interplanetary travel. The planets have to be in agreement. Mars must release you onto a solar path that will meet Earth months later, just as the outbound trip met Mars after a long curve around the Sun. Coming home repeats the deep lesson from the beginning. You aim for where Earth will be, not where it appears to be tonight. After launch from Mars, the ascent vehicle would likely meet a waiting spacecraft in orbit. Rendezvous is delicate work anywhere, and around Mars it carries extra importance. The crew rises from the surface, reaches orbit, matches speed, aligns, docks, transfers, checks systems, and prepares for the long crossing back. Beneath them, the planet that held them for so long becomes a globe again. The habitat may still be visible only in memory. The tracks outside it begin fading under dust. The return cruise is another season in deep space. Bones, muscles, sleep, radiation shielding, food, water, air, repairs, companionship, all of it continues. The crew is heading home, which is emotionally enormous, but the spacecraft still has to live properly every day. A journey back from Mars would take months under many current mission designs. The relief of leaving the surface would be real, and so would the need for steady care. Earth would slowly brighten ahead. At first it might be only a star among stars, then a tiny disk, then a blue-white world growing larger until oceans, clouds, and continents become visible again. Imagine seeing that after months near Mars, blue not as decoration but as shelter. White clouds, thick air, liquid water, whether forests, cities, the soft glowing web of everything familiar. Earth would look impossibly alive. Arriving home has its own physics. A spacecraft returning from Mars approaches Earth very fast, often faster than a spacecraft returning from the Moon. The heat shield must protect the crew during atmospheric entry, when the air itself becomes the brake. Earth's atmosphere is wonderfully useful, and also energetic enough to wrap the spacecraft in glowing plasma. The same atmosphere that gives you clouds and rain becomes, for a few minutes, a roaring cushion of heat and pressure. It is a beautiful bargain. The planet slows you down by making you burn against its air, while the heat shield quietly sacrifices its surface to keep the inside safe. After that, parachutes or other landing systems finish the descent. The capsule drops toward ocean or land, depending on the design. Recovery teams wait, doors open, fresh air comes in. Gravity returns in full strength, perhaps feeling heavy and strange after so long away. The body that adapted to microgravity and Martian gravity has to remember Earth again. Standing up may become its own small adventure. Earth, in her usual subtle way, welcomes you back by making your legs complain. And still, that heaviness is home. This return difficulty helps explain why Mars is so much harder than the Moon. The Moon trip is a difficult loop close to Earth. Mars is a full planetary campaign. Depart at the right time, survive the crossing, land through awkward air, live on a cold surface, make or manage resources, launch from another planet, meet a spacecraft in orbit, cross the solar system again, and enter Earth's atmosphere safely. Each step depends on the others. Each step asks for patience. Yet the return also gives the whole journey its tenderness. Mars is fascinating, but the story is never just about going away. It is also about carrying home with you, keeping it alive in a habitat, seeing it as a bright star in the Martian evening, then crossing the dark again until that star becomes the world beneath your feet. Remember that tiny blue dot from earlier. The farther it seems, the more precious it becomes. And somewhere inside that long route home is the reason Mars keeps calling so softly. It is difficult because it is real. It is hard because it is distant, moving, cold, dusty, and independent. The challenge does not make it less beautiful. It gives the beauty depth, like a red horizon slowly darkening under evening light while Earth waits beyond the sun's wide road. The challenge does not make Mars less beautiful. It gives the beauty depth. After all the careful pieces of the journey, the long crossing, the difficult landing, the thin air, the dust, the cold, the human body trying to remain strong, the delayed voices moving through darkness, the small habitat glowing on a frozen plain, the hard road home, Mars begins to feel less like a destination and more like a mirror. It shows you what exploration really asks from people. It asks for patience before speed. It asks for humility before confidence. It asks for design, trust, restraint, and a strange tenderness toward fragile things. The Moon taught humanity that another world could be reached. Mars teaches that another world can be studied across decades, approached with care, and maybe one day lived beside for a while. The Moon was the first hand placed on the wall beyond Earth. Mars is the hallway beyond that wall, dimly lit, immense, waiting with red dust along the floor. From far away, Mars has always looked like a promise. Ancient observers saw it wander across the sky with a reddish glow and gave it names tied to fire, iron, and war. Later telescopes turned it into a disk. Then spacecraft turned it into a landscape. Every age has looked at Mars and found a different meaning there. A red star, a god, a possible twin, a dying world, a laboratory of ancient climates, a place where rivers may have flowed. A place where life, if it ever appeared, may have been small, quiet, and hidden. That possibility changes the feeling of the planet. No one knows whether Mars ever had life. The evidence does not allow a simple answer. What we do know is gentler and still extraordinary. Long ago, Mars had liquid water on its surface. It had lakes in some regions, rivers in others, minerals that formed in watery conditions, and environments that may have been friendlier than the dry world we see today. Mars was never Earth, but it may once have shared a few of Earth's ingredients: water, rock, chemistry, energy, and time. Time is the soft giant in this story. Over billions of years, Mars changed. Its atmosphere thinned. Much of its surface water vanished, froze, escaped to space, or became locked underground. Its magnetic shield faded early in its history, leaving the atmosphere more exposed to the solar wind. The planet cooled into the desert we explore today. Yet the old traces remained: channels, deltas, clays, sulfates, layered sediments, dried basins, minerals like preserved sentences in a book written by water. The Moon preserves history too, but in a different voice. Its surface remembers impacts, ancient lava flows, and the early violence of the inner solar system. Mars remembers planetary change. It remembers climate. It remembers the loss of air and water. It reminds you that planets have biographies. They are not just objects. They are places with chapters. Earth has a biography as well, though ours is still warm and moving. Our air is thick. Our oceans are restless. Our surface is constantly rewritten by plate tectonics, weather, rivers, plants, cities, and time. Mars, quieter and colder, keeps older pages near the surface. Studying Mars helps us understand what makes a planet habitable, how climates shift, how atmospheres are protected or lost, and how rare Earth's long comfort may be. This is where the difficulty becomes meaningful. Mars is not hard because the universe is being dramatic. Mars is hard because real worlds are complex. Distance is real. Gravity is real. Radiation is real. Dust is real. Biology is delicate. Machines fail. Communication takes time. Return windows open slowly. None of these facts are cruel. They are simply the terms of the larger cosmos. And there is peace in accepting terms. You can imagine standing in a future habitat, looking through a small, thick window at the evening sky. The sun has dropped low. The dust has turned the light amber. The ground outside is covered in rover tracks, boot prints, sensor cables, and the faint marks of careful work. Somewhere beyond the horizon, a robot is charging its batteries. Somewhere overhead, an orbiter is passing through the dark, waiting to relay messages home. Earth is a star near the horizon, bright and tiny. Inside, the habitat hums. Air moves through filters. Water cycles through pipes. A plant leaf trembles under a small fan. Someone writes notes after a day of studying ancient lakebed rocks. Someone laughs softly over a meal that tastes better than expected, which is always a major scientific achievement. Someone checks the oxygen system for the third time because peace on Mars is built from repetition. That scene is not loud. It is not a heroic statue. It is ordinary life held carefully in an extraordinary place. That may be the most beautiful part. Exploration is often imagined as flags and footprints, but the deeper story is maintenance, observation, and care. It is making sure the heater works. It is labeling samples properly. It is saving power during a dust storm. It is taking one more image of a layered rock because the layer might remember a vanished lake. Mars is harder than the Moon because it asks humanity to grow up a little more before visiting. The Moon can be reached quickly enough for boldness to carry a mission. Mars requires boldness, but it also requires systems that endure, crews that cooperate, tools that repair tools, habitats that recycle, plans that survive silence, and a relationship with distance that feels almost philosophical. The Moon keeps Earth large in the sky. Mars makes Earth small enough to cherish differently. That tiny blue dot from earlier returns here, brighter in memory than in the Martian sky. From Mars, Earth would look fragile not because it is weak, but because distance reveals its delicacy. All the oceans, storms, forests, languages, songs, kitchens, streetlights, and sleeping neighborhoods fit into one point of light. The farther away you go, the more home becomes a single shimmering idea. Mars' difficulty, then, is also a lesson in love for Earth. The more we learn about cold deserts, thin atmospheres, and lost water, the more astonishing a living blue planet becomes. The more effort it takes to make one breath on another world, the more miraculous an ordinary breath feels here. The more carefully a habitat must recycle water, the more beautiful rain becomes. And still, Mars keeps calling. It calls through the color of its evening sky, through the silence of its plains, through the mystery of its ancient rivers, through the patient work of rovers, through the thought of human footsteps in dust that has waited longer than any human story. It calls because it is hard in the way mountains are hard, oceans are hard, and music is hard. The difficulty gives shape to the longing. The Moon was the first nearby wonder. Mars is the farther wonder, the one that asks for a slower courage. It does not promise comfort. It promises perspective. It offers a place where science, engineering, and imagination meet under a muted sky, all of them speaking softly because the planet itself seems to prefer quiet. So the journey ends where it began, with your eyes moving between two lights in the night. The Moon, pale and close, still carrying the memory of first steps. Mars, red and distant, still holding its questions. One teaches nearness. The other teaches patience. Together, they draw a gentle map of human curiosity, from the familiar lantern above the rooftops to the ember far beyond, glowing softly as the planets continue their unhurried dance. The room around you is quiet again. The night outside rests against the window. Somewhere above the clouds, the Moon moves through its familiar path. Farther away, Mars continues around the Sun, keeping its ancient silence, carrying its dust, its ice, its buried histories, and its patient red light. The world can feel softer from here. The journey to Mars is difficult, but you do not have to carry that difficulty tonight. You can simply hold the image of distance made beautiful. A small spacecraft crossing sunlight, a rover waiting under a pale sky, a habitat glowing like a warm thought on a cold plain, Earth shining as a blue star, small and precious, watched from far away. The universe is vast, but it is not in a hurry. The planets move without strain. The moon circles. Mars drifts onward. Earth turns gently beneath you, carrying oceans, cities, forests, and all the quiet rooms where people are listening, resting, breathing, and slowly becoming still. There is nothing more to solve right now. The red planet can keep its mysteries a little longer. The machines can keep their patient watch. The dust can settle over stones older than memory. The stars can remain where they are, bright and distant, needing nothing from you. Your own breath can be simple again, easy and warm. The moon is nearby. Mars is far away. Earth is here. And here is enough for tonight.